Here we have two Kubota V3800T engines with Mecc Alte ECP32 1M/4 alternators. We just got a PDA control box on the top, so for display, so you can see the voltage and the current. If you're over at the gensets, we made these from scratch, 100%. On the end here, this particular unit, we've used two different speed controllers. We've used the old analog style GAC speed controller. So these are in sync, wired up to a GC600 and a DST4602. And over here we have a digital speed controller from GAC, which is the EEG 7000 series. So this is the common bus that we made up. So inside we have a contactor, a load contactor from each generator, generator 1, generator 2. We've got the incoming supply from each generator coming into the breakers, and obviously they feed to a common bus on this bus bar right here. So generator 1 here, we have a DST4602. This is actually the base box version, and this is the HMI, the display. And then we have the GC600 here for generator 2. Now we'll open this door and we'll have a quick look. So in here you see the base box here for the DST. And here you'll see the back of the GC600 and the back of the remote display. So these two controllers, the base box and the GC600, there's a CAN bus cable that goes between that shares all the synchronizing data, so the kilowatts, the VARs, so it can share. And here we have a reactive load bank, so it's good for our VARs. And then over here we have a resistive load bank, so the power factor is obviously unity, so that's good for getting the load in kilowatts. So what we're going to do two steps here. So the first step is going to get very, very noisy when we start it. So we're going to start both sets up and we're going to parallel them together. So you can see the synchroscopes, you can see the errors, and you'll see the controller reducing the error before it closes the breaker. So we'll close the DST4602, start that up. Now we're going to start the GC600 and we'll let it sync to the DST. So you can see on the synchroscope, when we go to close it, you'll see a frequency differential and a voltage differential. These will drive back into sync before it closes. So you see on the screen here that these two sets are in parallel. There's a tiny little bit of recirculating current, very, very little. So we're fluctuating, the total load is less than half to 1 kilowatt between both sets. So you'll see here we've got 43 kilowatts of total load. This set's punching out around about 21.5 kilowatts. This set's punching out around 21 kilowatts, so the load is still the same, the total load. So these sets are sharing 50% load each. at the moment that is a resistive load, there are no K-bars. We're just going to be a quick view on the different pages on the DST 4602. Now the GC 600. So the next step, what we're going to do now is introduce some K-bars. So we've reduced a little bit of the resistive load back and we've introduced some K-bars. So now you see we're sharing very, very well. We're around about 40 amps, 45 amps a phase, and this unit is almost identical. So we're sharing, again, 50% of the bars between sets. You can see the power factor sitting around about 0.6. What we're going to do now is do a demonstration of the system automatically starting as the load increases. So basically, when generator 2 gets to 19 kilowatts, 60% of its load, then the DST is going to start up, close its breaker. You can see at the moment the DST is starting, and it will close its breaker because the load over here is above 19 kilowatts. The reverse is going to happen when we reduce the load down to 12 kilowatts, then the DST is going to come off the bus and the load will be taken 100% off of the GC 600. So there you see the load is basically zero. This here will be now shutting down. It's in shutdown mode, so it's got 44 seconds before it shuts down.